Hello, everybody. My name is Laurie. I am VP of Developer Relations at LlamaIndex. I've been a developer for 27 years, including a little bit there where I was the co-founder of NPM Inc. Today, we're going to be talking about unlocking your data with AI-powered Retrieval Augmented Generation. Retrieval Augmented Generation is quite the mouthful, but it's not that complicated, so let's break it down. First, what is AI? It's a big field and it means a lot of things to different people. But the thing that most people are excited about right now is a thing called large language models, or LLMs. You've probably heard of ChatGPT. ChatGPT is an LLM. Think of the phrase, the cat sat on the. You can probably complete this sentence. That's what an LLM is. It takes a sentence and it completes it. If you give it a question, it answers the question, because an answer is usually what comes after a question. But how does it do that? What it's actually doing is math. Imagine you gave a computer every book in the world to read, and then you got it to construct a list of every 3-word phrase in all of those books. Then for each of those phrases, you got it to make a list of all of the words that came next, and then you ranked them by how often that happened. Then you gave it the phrase, the cat sat on the, and you asked it to predict what word would come next. Based on those lists it made, the next word would almost certainly be mat, because in all of the English language in the world, that's how that phrase is most often completed. The math that an LLM is actually doing to figure that kind of stuff out is a lot more complicated than what I just said, but it's not so much more complicated that it isn't a decent mental model of what's going on. So now take that list that we had and use it again. Give it the capital of the United States is. It would probably give you Washington, D.C., because, again, that's just a really common phrase. But already something interesting is happening because it looks like a computer knows something, knows the capital of the US, but it doesn't. It's just doing word completion. So now take this sentence completion and scale it way, way up to millions and billions of words, and you get ChatGPT, the LLM that everyone's been talking about. You give ChatGPT a question, and it will give you what appears to be an answer, like the one I've shown here. It not only knows that the next word should be mat, but it gives you context about why. But this isn't doing anything fundamentally different. It's still just doing that same math, just at enormously high scale. It doesn't actually know anything, but it sure looks like it knows things. And at some point, the difference ceases to matter. Computers until now have been very good at processing data. They can stack up huge piles of data, sort it, filter it, move it around, spit it back out, all at enormous speed and impressive scale. But what they haven't been able to do is turn data into information. They haven't been able to understand what they're working with. But now, if you give a computer enough context, it can appear to reason about that information. Let's take this example. It figures out a conclusion from a related set of facts, namely how old Susan is. What's really interesting here is that this set of facts are not part of the set that it was trained on. When it read all of the books in the world, Susan's age wasn't in there. In fact, I never told it Susan's age. At some point along the line, prediction of the next most likely word became reasoning. This is the surprising and frankly kind of spooky outcome that has made LLMs so interesting to so many people. This transition of software from being a tool that we use to a sort of low-level assistant that we can partner with is going to change every piece of software out there. Software that doesn't have the ability to understand what it's working with is going to begin to feel strangely limited, perhaps even broken. It's a very exciting time to be working in software for that reason, but there is a problem with this brave new world. LLMs know all sorts of things about the world. They have enormous mountains of data, but they don't have your data. It would be terrifying if they did, because where would they get it? Your data is sitting in a SQL database or a Notion wiki or your Slack or behind the API that you build. LLMs can't answer questions about your data because they don't have it. The obvious solution is, so give them your data. And to some extent that works. ChatGPT now accepts over 100,000 tokens of context, which is like 2 whole books. So you can upload all of Moby Dick to ChatGPT and then ask it questions about Moby Dick. Unfortunately, that only works up to a point. Does your organization have more than 2 books worth of data? It almost certainly does. What happens if you can't cram all of the context you need into the prompt? This is the problem that Retrieval Augmented Generation was created to solve. By generation, we just mean answering the question. So what does retrieval augmented mean? It means instead of giving an LLM all of your data, give it just the most relevant data. So the answer from the LLM is augmented by your data, which you've selectively chosen through retrieval. But how do you know what data is the most relevant? Luckily, the same math can come to our rescue. You can split your text up into chunks and give those chunks to the same LLM. It will read the chunks, figure out what they mean, and convert that meaning into numbers, just like it did with all of the other text. Those strings of numbers to represent text and their meanings are called vector embeddings, or just embeddings for short. And the range of possible numbers is called the vector space. Vector embeddings allow you to do a mind-blowing thing. If you have a question, you can give the question to the LLM and it will convert your question to numbers, just like it did with all of your chunks of data. The question will mathematically end up close in vector space to the chunks that contain the answer because the meaning of the question and the answer are similar. The result is that you can rank all of the text chunks you have by how similar they are in meaning to the question you have. This isn't keyword matching. This is called semantic similarity ranking. So then you take the most highly ranked chunks of text and you give those to the LLM as your context, as many as will fit, along with your question. Now your LLM has all the data that it needs, plus that spooky reasoning power that it has to answer the question about your data, no matter how much data you actually have. This infinite context is the holy grail of retrieval augmented generation. But let's recap what just happened. The LLM turned the whole world into embeddings, and then it turned your text into the same embeddings, and it gave them back to you. Then it turned your question into an embedding and gave that back to you. You did some math on the question and your data and came up with the most meaningfully relevant data, and you gave that data and your question back to the LLM, and it gave you an answer. And it was the right answer, like 95% of the time. So far, so amazing. Doing all of that stuff is a bunch of work. You have to get the data, you have to split it up into chunks, you have to feed it to the LLM, you have to store that stuff, you have to convert the question, you have to do the math, you have to feed those back to the LLM again, and you have to get the answer back. All of that stuff is a pain to get right. So let's see how you do that in LlamaIndex. This is doing that in LlamaIndex. 5 lines of code, 6 if you count the imports. What's all of this doing? Let's break it down really, really quickly. This line is taking all of your original data, in this case from a directory on your hard drive, but it could be from a SQL database or your Slack or a Google Drive or anywhere that Airbyte can put your data for you. This is converting all of your data into those embeddings that I talked about. It's sending them all to OpenAI by default, and it's storing the resulting pile of numbers in memory, but it could store them somewhere else if you wanted. And these 2 lines are turning your query into an embedding, doing the math to figure out what context is closest in vector space, and sending your question and the relevant context to OpenAI. And finally, there's your response. This is the value prop of LlamaIndex. It takes all of that work and it makes it very, very simple. Here's my favorite example. I took 60,000 of my tweets and I gave them to LlamaIndex, which indexed them all up for me. And now you can ask this app what I think about stuff based on all of the stuff that I've ever tweeted. It knows quite a lot about me and also my opinions about Star Trek. What about a real example, an example that's actually useful and not just a toy? Here's secinsights.ai. You give it official company filings, and then you can ask it questions about those filings. In this case, I asked it about the trend in Apple's profits over 3 years, but I could also have got it to compare 2 companies. You can see it reading several documents and then synthesizing a single answer out of the facts that it has gathered and drawing conclusions. This is such a good example, this is such a good idea, that there's now a startup doing exactly this as their whole product, not just as a demo. Obviously, the 5-line example that I gave you is the very simplest way to use LlamaIndex. But if you're interested in the power that LLMs have to understand your data, we invite you to dive in. docs.llamaindex.ai has everything you need to get started, and our Discord is full of friendly people who can help answer your questions. Thank you all so much for your time and attention.